Good morning to one and all. This is Padmavati. I'm working in Sri Venkateswara College of Engineering, Bangalore, in the Department of Computer Science and Engineering. Today, we are going to discuss a topic on compression. So, let's see what is compression. See, compression is nothing but reducing the size of the data and transmitting through the channel so that it reduces the bandwidth. In where we are using the compression is we are using in military applications and as well as a digital image watermarking. So before that, we will see what is watermarking. Watermarking is nothing but, for example, I have example, you consider this as an image. At the back end, I used to attach some kind of textual data. So that data will be hidden and it can be transmitted. So the person who sees outside will be seeing only this image and he can't able to read the data which is hidden backside of the image. So where we are using compression is nothing but we are using this kind of compression in image watermarking, which is used for military applications. So before starting to compression, let's know about compression ratio. Compression ratio is nothing but it is a ratio of N1 by N2. We'll see what is N1 and N2. N1 is nothing but the amount of data that is to be compressed, that means it is before compression. And N2 is nothing but amount of data that was compressed. That means it is after compression. So compression ratio is nothing but amount of data to be compressed to the amount of data that was compressed. It's called compression ratio. Then we'll go for redundancy in compression. There are various types of redundancy. The basic two types of redundancy is statistical redundancy and psychovisual redundancy. And in statistical redundancy, we have two types. One is interpixel redundancy and other one is coding redundancy. And in interpixel redundancy, you have spatial redundancy and temporal redundancy. Let's see what is the coding redundancy. See, in coding redundancy, code is nothing but a system of symbols. That means it has letters, numbers, bits, which is used to represent the body of information or the set of events. Each piece of information or event is assigned as a sequence of code symbols is called a code word. So the number of code symbols in each code word is called a length. The 8-bit code that are used to represent the intensities in most 2D intensity arrays contains more bits than are needed to represent the intensities. And here in number 5, you have 3 digits which is used to represent. And here the code length is 3 and the symbol which you used is zeros and ones. So this is an example of the coding redundancies. And next we'll go for interpixel redundancy. See here, we can use run length coding here. See here, there is a number 1 present here, which is nothing but the square which is present in the middle. So this white square is represented as 1 and this black background is represented as 0. So as we all know, in black and white image, that is binary image, black represents 0 and 1 represents white. And here you have black as well as white, which is nothing but the binary representation. And this can be scanned in a single line and we can encode the complete representation. And next we'll come for psychovisual redundancy or something called as the irrelevant information. See, irrelevant information from the name itself, we can identify that information is not relevant or the information is repeated or the information is with that information we have no use or it just occupies the space where we are transferring. So most 2D intensity arrays contain this kind of information which is ignored by the human visual system, or it may be considered as a extraneous to intended use of image. So it is redundant in the sense which is not used. So then we'll go for the psychovisual redundancy. In psychovisual redundancy, see, we have our eye has a capacity to resolve only 32 gray level values only. So the basic psychovisual redundancy is nothing but some information where our eye that leaves, that is called as the psychovisual redundancy. Or sometimes the eye does not respond because of the sensitivity to all kind of visual information. And this kind of redundancy can be removed using quantization with a limited number of output values. And next we'll move on to fidelity criteria. In fidelity criteria, there are two types. One is objective fidelity criteria, and the next one is subjective fidelity criteria. The objective fidelity criteria is nothing but it is an amount of error which is present in the reconstructed data, and subjective fidelity criteria is measured by the human observation. And here, after seeing that, we can just give the values. We will be just giving whether it is excellent or it is fine or it is average or it is poor, something like that we'll be giving. For example, excellent means the picture will be of high quality. Fine means it is of high quality, but some interference will be there, which is not objectionable. And passable means it is acceptable quality where the interference is not at all objectionable. And marginal means it is of poor quality. Inferior means it is very poor quality. Unusable means the image quality is so bad we can't watch or we can't use that image. So here it ends the topic of image compression. And here we have seen what is compression, what is compression ratio, and what are the types of redundancies, and what are those redundancy, and how we can use in fidelity criteria based upon your image. Thank you.